In a previous lesson, we explored the types of potential and kinetic energy that you can see on the macroscopic, which means large, everyday level. In this lesson, we'll explore ways in which potential and kinetic energy are illustrated on the particle level. First, we're going to talk about kinetic energy. Now, on the macroscopic, large level, we might see kinetic energy as a car rushing down the road, or anything else that is moving. On the molecular level, the particles that make up matter are always moving and bumping into each other. Because they're moving, they have kinetic energy, and we call this energy thermal energy. Thermal energy is energy that's due to the movement of particles within a substance. Thermal energy is defined as the total kinetic energy of all the atoms and molecules that make up a particular substance. Every substance has thermal energy because the atoms and molecules in it are always moving. Thermal energy depends on how much stuff there is in a sample. Another way to say this is it depends on how much matter there is. A large bucket of boiling water, for example, will have more thermal energy than a small cup of boiling water will, and that's because there are more moving particles in the bucket. The faster the particles are moving, the more thermal energy a substance has. And this might make sense if we think about the big level where you have a car. If you put more energy into the car, it will move faster. The same thing happens if you put more energy into the particles that are in a substance. Let's talk about temperature for a minute. Temperature is not the same thing as thermal energy. Temperature is a measurement, and it's a measurement of the average kinetic energy of the atoms and molecules in a substance. Now let's take a step back and see what this means. The particles in a substance don't all move at the same speed. When individual particles bump into each other, sometimes they speed up and sometimes they slow down. The faster a particle moves, the more energy it has. But since not all particles are moving at the same speed, not all particles have the same kinetic energy. When we measure temperature, we are measuring the average of all the energies of these particles. Because some are slow, some are fast, we're taking the average. The higher the temperature, the higher the average kinetic energy of the particles, which means the more particles are moving really, really fast. Unlike with thermal energy, temperature does not depend on the size of your sample. Imagine you have two containers of water, and both of them are different sizes, but both of them have the same temperature. Now, the one on the left has more thermal energy because it has more particles that are moving. But just like in the cup, some of the particles are moving really fast and some of the particles are moving slowly. And since temperature has to do with the particles and how they are moving, if both containers are at 100 degrees, the average of the kinetic energies of the particles is going to be the same. So they both have the same temperature. The last thing I want to talk about is heat. Heat is also not temperature, and it's not thermal energy. Heat is the transfer of thermal energy from one body to another because of differences in temperature. So heat measures how energy moves or flows, and sometimes we use the term heat flow. In order to have heat, thermal energy must be moving. Heat is not the same thing as thermal energy, but if you add heat, you will increase the thermal energy of a substance. Heat is not the same thing as temperature, but it can result in a temperature change because it'll make all the particles move faster. Heat always flows from the hotter object to the colder object, never the other way around. So if you were standing near a space heater, The heat is going to travel to you. Your cold is not going to travel to it. Heat always travels from hot to cold. In summary, you should now be able to explain the difference between thermal energy, heat, and temperature. You should be able to explain how energy is related to the movement of the particles in a substance.